Imagine discovering that something as massive and powerful as a solar flare is far more intense than we ever imagined. This isn't science fiction. It's the groundbreaking conclusion of new research that suggests solar flares may reach temperatures up to 6.5 times hotter than previously estimated. For decades, scientists have been puzzled by the behavior of our sun during these explosive events. But this study from the University of St. Andrews might just rewrite the textbooks. Solar flares are among the most dramatic displays of energy in our solar system. These bursts of energy erupt from the sun's outer atmosphere, sending shock waves of heat and radiation into space. During these eruptions, parts of the sun's atmosphere can soar to temperatures greater than 10 million degrees Celsius. Such extreme conditions flood Earth with heightened levels of X-rays and other forms of radiation, posing risks to satellites, astronauts, and even our planet's upper atmosphere. But here's where it gets controversial. What if the particles within these flares are not just hot, they're superheated, beyond anything we've calculated before? Published in the Astrophysical Journal Letters, this research dives deep into how solar flares manage to heat plasma to such extraordinary levels. Plasma, for those unfamiliar, is essentially a soup of ions, positively charged particles, and electrons, negatively charged particles. Until now, scientists assumed that both ions and electrons would share similar temperatures during solar flares. However, the new findings challenge this long-held belief. Dr. Russell explained, "We were inspired by recent breakthroughs showing that magnetic reconnection, a process where magnetic field lines snap and reconnect, can heat ions much more effectively than electrons. In fact, this phenomenon appears to be universal, having been observed in near-Earth space, the solar wind, and advanced computer simulations. Yet, until now, no one had connected these insights to solar flares." Magnetic reconnection is like nature's way of releasing pent-up energy, and understanding its role could unlock mysteries about solar activity. But this is the part most people miss. The difference in temperature between ions and electrons doesn't vanish instantly. Modern calculations reveal that these disparities can persist for tens of minutes in critical regions of solar flares. This revelation opens the door to considering the possibility of superhot ions, an idea that has largely been overlooked in solar physics. And it's not just theoretical. The newly proposed ion temperatures align remarkably well with observations of flare spectral lines, which are bright enhancements in solar radiation at specific wavelengths. For nearly 50 years, scientists have wrestled with why these spectral lines appear broader than expected. Traditionally, the explanation leaned toward turbulence, chaotic motions within the flare, but identifying the exact source of this turbulence has proven elusive. Could it be that the answer lies not in chaotic motion, but in the sheer heat of the ions themselves? The new research argues for a paradigm shift. Perhaps the broad spectral lines aren't solely due to turbulence, but also reflect the incredible temperatures of the ions. This discovery raises intriguing questions. If solar flares are indeed this hot, what does that mean for our understanding of stellar phenomena? How will this impact future space missions or technologies designed to withstand solar storms? And perhaps most provocatively, should we rethink some of the fundamental assumptions guiding solar physics today? So what do you think? Does this finding excite you, or does it raise doubts about the reliability of past models? Share your thoughts in the comments below. We'd love to hear whether you agree or disagree.